So here's our running order today. As I said, my name's Di Clegg, but the people you really want to hear from today are Mark Watson, CTO of WorldRemit, which is a London-based leading payments company, and David Walker, who is the EMEA field CTO for Yugabyte. No spoilers for their presentations, but I think it's pretty obvious that Mark's here to talk about just exactly why WorldRemit chose to go with Yugabyte and how they plan to transform Yugabyte technology into business value for WorldRemit. And David is going to follow that up with a bit of a drill down on some of that technology and how it can deliver the value that Mark is looking for. So without any further ado, I'm going to duck out of this and hand over to you. Mark, are you ready to roll?
I am. If you just...
I'm stopping sharing. You can
exactly. And I will bring up my presentation. Can you see that?
I see that.
Cool. Hello, everyone. My name is Mark Watson. As has been mentioned, I'm CTO at WorldRemit. I've been in that role since October 2018. I'll give you some background on WorldRemit and how we've come to a relationship with Yugabyte. I also have on the call my VP Engineering, Olivier Servin. Olivier is going to... The way we've devised this is if anything comes up that is remotely complex, I'm going to hand it over to Olivier and he's going to answer the question, especially in terms of kind of some of the implementation questions that we might have. Let me tell you a little bit about WorldRemit. Firstly, as it says there, we're a leading global payments company. The clue is kind of in the name. We specialize in international remittance. We allow users in one country to send money, typically in another currency, to users in another country. We were founded in 2010. We're about 1,500 employees, of which around 300 in technology and product. We send money from around 50 countries to over 130 countries worldwide in 70 different currencies. That means that we've got a fairly complex network of pay-in and pay-out systems. We have different money acquiring systems in our send countries. And we have a large number of payout mechanisms across our receive countries. So we talk in terms of corridors, which are pay in, pay out combinations. And we have 5,000 of those. If you measure it in terms of multiply that by a number of currencies, then we have actually 9,000 payout services across the piece. Because it's worldwide and probably after Western Union, probably the largest of this kind of payment network, we have to run 24 hours and therefore operational resilience is very important to us, as I'll come on to. We are hiring, as it says at the bottom. If you are actually interested in a job, then you'll see this link on subsequent pages if you want to write it down while I'm waffling away. Why have we ended up using Yugabyte? Well, it's part of an overall process of transformation, and in particular platform transformation that we've been running since late 2018. So at the point where I started here, it was a largely Microsoft shop with a monolithic architecture surrounded by services written in various flavors of .NET, including ASP.NET, .NET Framework, .NET Core. Quite a lot of services have been built around that. It's become very complex, quite difficult to extend, and quite a lot of those services had their own platform as a service, SQL Server databases as well. And as you can imagine, you don't start off with 9,000 payout services. You start off with a small number, and then you kind of accrete over time. And so the network had built up from being something relatively simple to being something fairly complex. Our back office services were and still are in AWS, data warehouse, and so on. We have web and native mobile applications, but given that complexity and given the age of some of the systems, it was very difficult to extend the platform. And it also had quite a lot of resilience risk, in particular if you look at .NET Framework, for example, that effectively runs in a service in Azure, which was not particularly resilient and quite difficult to extend. There have been various attempts to extend it to provide multi-data center resiliency, and they had mostly not worked out. So we embarked on a series of parallel tracks at that point as a modernization program. We actually went out for an RFP to all the cloud providers, including Microsoft, but also Amazon and Google. We could have, if I'd been a betting man at that point, or if I were one still, then I would have bet on it, ended up on Azure, but Amazon did a better job of selling, I think, and it would have been a significant migration, whichever. In fact, the Amazon migration was cheaper than the one that was bid by Microsoft in that case. So we ended up moving everything to Amazon, including the monolith architecture that we had. As part of that migration, we repackaged everything in Docker and Kubernetes and went to a multi-availability zone architecture there. And also, we started a long-awaited reconstruction of the platform itself. So we started to move away in terms of the core monolith from this big SQL Server database to Apache Kafka being the main source of truth. And then as you do, you have to kind of run the two things alongside each other. You run mostly AWS alongside Azure, and so you end up with a multi-cloud architecture, whether you like it or not. And you run Kafka in synchronization with your SQL Server database. So this is going to kind of simplify things quite a lot. This was the architecture that we had beforehand. As you can see, we had machine learning and data warehouse. Along the bottom was sitting in Amazon. Most of the services, however, sitting in Azure using various kind of proprietary bits of Azure with this great big database in the middle of it, and quite a lot of platform as a service databases sitting in these orbiting services that have been built. So we rebuilt that into this. There is still some vestigial use of Azure sitting alongside this. So there is still some kind of bridging to legacy services, but this is the kind of main service we've ended up with. It's got a Kafka core. We also using MongoDB for document services. As I said, using Kubernetes for packaging. We've still got the data estate sitting on Amazon as it was before, a bunch of new services, and also ingress via an API gateway from Kong. You'll notice PostgreSQL in there. So we took a decision, and I'll talk about this in a very short while, to move away where possible from SQL Server to Postgres. And that's actually the core of many of the microservice databases that we have. So how and why did we come to Yugabyte? Really, there are two main reasons. One is that we really have a requirement for resilience, and we're constantly trying to build up our capabilities in terms of resilience. We have, as I said, a global network, which has to be up 24/7, both for front office and back office. And so we have customer service centers across the world, as well as the main transactional platform. Our regulators have increasing operational resilience requirements. So in particular in the UK, the FCA has now drafted and issued operational resilience requirements that we will have to satisfy by the end of first quarter next year. And we expect to see those rolling out across other jurisdictions over the next 18 months or so. We have relatively few maintenance windows where we could actually take the service down. You're really at some point going to be sacrificing business to take the service down at all. So we need the service to be constantly running, and it needs to be able to withstand instability or loss of infrastructure. The main region in which we run for Amazon is in Frankfurt. That had effectively a data center loss a few weeks ago. It's unusual, but not unheard of to lose an entire region. But it's also quite possible to lose what Amazon calls an availability zone, which is one of its data centers. We lost one in our main region the other week, and we're able to heal over within the region. Obviously, we also need to be able to do that at a multi-region level as well. And although we've moved the main database and the main source of truth for the data to Kafka, we have 200 to 300 microservices, each with their own individual database needs, and they need to be able to fail over without waiting for rehydration or a rebuild. So we need to be able to run those effectively in live mode as well. So the first part of the business justification for Yugabyte was basically to have use it for these smaller databases to fail over without loss of data. The Kafka service is using Kafka replication. If you're familiar with that, it has its own way of doing things. But by and large, the services, the microservices own their own data and have to be capable of failing over and picking up without loss. There's a second dimension to it as well, which is one of cost. So we'd already taken a decision to move the smaller databases from SQL Server to Postgres. One of the things about if you move from, in particular as we've done from Azure to Amazon, is that Microsoft's smallest SQL Server instance is cheaper by about a third, rolling back from 25% more to a third less than Amazon's is. And so if you're running lots and lots of small databases, you then have to figure out what you're going to do about them if you move away from Microsoft's ownership of SQL Server to running on a third party. The solutions that present themselves are you can either convert to an open source database. So we started to do that anyway, and we'd switched from SQL Server to Postgres for new services over time. And then you've got to figure out how you're going to then manage those databases. Postgres doesn't offer the same capabilities that SQL Server does in that regard. And so a second solution is basically to put them in a single database orchestrator and manage them as one. And from our point of view, we expect Yugabyte to do that job, and through that mechanism to save us a fair bit of money. So where are we now in terms of migration? We did a fairly long POC, which is about 2 or 3 months, which Olivier can talk to the detail in terms of if there are any questions about that. We're still in the process of production migration. As it says there, Yugabyte is part of a larger scale operational resilience plan for 2021, and it's part of our plan to meet the regulatory requirements that have been placed on us. So we're kind of looking forward to getting it in production, looking forward to rolling it out. Our experience with it thus far have been very encouraging. At this point, I'm happy to take questions.
I don't have any questions, Mark, coming from participants, but I did have a couple of people ask me questions beforehand that maybe I would like to ask right now. So the first one is, how complex are you finding the porting from Postgres apps to Yugabyte? Any gotchas?
Olivier, do you want to pick that up?
Yeah, I can. So in a nutshell, very not complex, because at the end of the day, the big work for us was to port from MS SQL to Postgres. But from Postgres to Yugabyte, it's trivial, because at the end of the day, the engines are compatible. So for us, it was very easy. We don't use stored procedures in our Postgres, so there's no double check there in terms of is the code going to work exactly the same in Yugabyte. It was very easy for us, really. It's just simple as SQL. So the porting is really trivial. The one thing that we wanted to check was about the scalability and the load testing. That was also fairly easy to assess. So we didn't find any hiccup along the way, really. It was fairly easy.
Thanks, Olivier. Actually, whilst you were talking, there's another question just did pop up from somebody called Jonathan Lowe, which is, what did the POC uncover about Yugabyte, both good and bad? And I did have another question, which was, what were your success criteria for the POC? So maybe you could talk a little bit about the POC generally.
Yeah, sure. So the POC was to assess a few things. First of all, was it a good match for us in terms of our disaster recovery strategy? So how easy is it for us to fail over from one AZ to the other, from one region to the other? What is the experience from a DevOps standpoint, from an engineer standpoint, from a DBA standpoint? That was important. Another part of the POC was obviously to assess any differences between Yugabyte and Postgres in terms of engines, because they are very similar, but they have a few differences. So we wanted to assess that part as well. And then the third thing was obviously the scaling. How did they compare in terms of loads, knowing that we have, like Mark was mentioning, hundreds of small DBs and not one big. So that was important for us. And finally, we wanted to make sure that if we were using some extensions on some Postgres hidden somewhere that I wasn't aware of, then we would find it and identify any potential issue. So that was the scope of the POC. We engaged a few engineers, a few DevOps engineers, a few DBAs to make sure that everything was going well. And so what did we uncover? So first of all, the command control from Yugabyte is pretty sleek. So that was the first comment from my team. They were like, oh, that's cool. That looks really polished and we like using the product. Then after that, we checked the various performance issues. We didn't find anything. We were very surprised actually that it was so easily in terms of comparison. We identified a few differences in terms of advanced storage-related type of features with Postgres, but it wasn't really a problem for us because, like I said earlier, we are not using any advanced type of features on Postgres. And that's it really. We didn't identify any major issues that we had to work with Yugabyte. Everything was kind of, well, that stuff was expected. We are not using it anyway. And it's really, like I was saying a bit earlier, advanced features that are mangling the Postgres engine. But everything that is, NC SQL was behaving completely fine. The indexes, the query plans, everything was the way we thought it would be. So it was a fairly easy journey.
Thanks, Olivier. We've got a bunch of questions, sorry, in the chat window and the question and answer window. So I need to pull one or two from each. What was the biggest database size that you're migrating? I think that the person in question is talking about migrating from SQL Server to Postgres, because you talked about breaking them up into smaller databases, didn't you?
Well, the biggest is hundreds of gigs, really. But then it's mainly related to the previous monolith architecture. Everyone familiar with the microservice type of architecture knows so well that then you just take chunks of this type of data. So, we went from hundreds of gigs to dozens of gigs. Now, in our microservice Kafka-based type of architecture, our DBs are merely glorified cache systems. They own their a temporary version of reality that is just their current state. But if we lose it, it's okay, because we can recreate it from Kafka. What matters to us is that as we want no disruption, it's better if we don't lose it at all. But we went from really one large hundreds of gigs to small gigs.
Okay.
Yeah. So the largest one is about. I mean, the main monolith was multi-terabyte and remains multi-terabyte because we still have to run it for some of the legacy services. But you know, in terms of the kind of business case for Yugabyte, it's really about solving the ones that are dozens of gigs.
Okay, thanks, Mark. I'm conscious of time here.
Yeah.
You need to get out. And for everyone who's asking the questions, we're going to come back and carry on the Q&A session after David's presentation. But David, can I ask you, are you ready to pick up the baton now?
Yes, if I can find the unmute button. I hope that's it.
Okay, I'll drop now. Thanks very much, everyone. Thank you.
Thanks, Mark.
Not very many thanks. Bye now.
Thank you.
Okay, David, then without further ado, over to you.
Okay, to share my screen. And before I dive in, I do want to actually thank Mark, who's dropped off, and Olivier as a team to work with. It's a new technology, and it was great fun working with them and their team. They've got a lot of very skilled engineers. And like Mark said, we're recruiting too, so we're competing for the same pool of very experienced engineers, if you know anybody. Anyway, I'm going to talk a bit about Postgres as cloud-native resilience for resilience and scale. And database resilience, as Mark alluded to, is becoming a business concern. We talk about resilience, but it's actually become more widespread than just the ability to deal with change or disruption. It's how do you get there? How do you plan to respond to all of these things? And the way I've been looking at this, especially after talking with people like Mark, is that there are three dimensions to this. There's the technical aspect, what happens if you lose a node and things, those are all important. But there's also an operational aspect to it. The operational aspect is about things like upgrades, expansion, elastic expansion and contraction of the database, dealing with peaks and so on and so forth. And the final dimension of it is the financial one, not having any hidden costs, being able to afford what you need to run to drive the business. So when you're designing and choosing a new system, building these three aspects into your design and having technologies to do this is really important. So I'm going to start with the technical resilience aspects. And with that, I guess that a lot of people out there are still building databases like this. It's fairly typical. It comes from the evolution of having a single data center and then growing out to 2 data centers and putting replication between this. And this has actually been a necessary thing to do. It's what's required because that's what the technology has been capable of. So you build 2 monolithic servers, probably just a single server each. You scale them up to the largest point, your peak load, and then you buy and manage a replication tool between them with all that comes with those ones. And you weren't going to open up into a 3rd data center because building a physical building, putting more kit in there, was all going to be expensive. And some people have done a lift and shift and brought that, as Mark described, they did this initially at WorldRemit. Lift and shift what they had into the cloud, but they start treating it just like it's on premise. This doesn't have to be true. With cloud technology, you can use them as multiple data centers. It costs nothing to have a 3rd, 4th, 5th data center. And it starts to open up some questions. When did you last test your DR plan? Did it work? And if you're going to fail over from a live instance to a standby instance, what are the RPO and RTO? Is that going to be acceptable in terms of what you want to run? And finally, given that these are monolithic databases and tools to run it all, how much is this going to cost you? So there's an option. You can now build a single, strongly consistent distributed database that uses 3 or more failure domains. And those failure domains could be a rack or an availability zone or even a region in a cloud provider. And instead of having 4 copies in the previous example, if you had mirrored disks under each of your monolithic databases, this has actually only got 3 copies. You can lose a whole region if it's built across 3 regions, because the database will still be core and be able to run. And your domain failure targets will be 0 because it's a consistent database. So if it was committed, it's there in one of the other 2 regions. And your recovery time is about 3 seconds. Part of that is associated with the raft consensus algorithm that we have at the back end of our technology. And part of that is just the application reconnecting if it was connected to a local node. This typical configuration is also built to meet your current CPU requirements rather than your maximum one, because it's elastic and because we can add more nodes to it. You don't have to have all the nodes and all the capacity run for your maximum throughput at any point. Not only does this let you deal with planned growth, but unexpected growth can also be dealt with without having any risk to the business. So what you get is a greater, moving from a two instance with replication to a single instance distributed across 3 regions, gives you a more resilient but lower cost solution to what you're trying to achieve. And this then comes with operational resilience. And there's lots of aspects to that, and I'd like to just pick on a couple of these. The first I want to pick on is elastic scalability. If you're adding more nodes to or more capacity to a monolithic database, you add more disk. If you want more processing, you can bump the machine up probably with an outage to add more cards from 16 to 32 to 64 cores, whatever it takes. But these both come with a cost. That means adding more, taking the system down, adding the infrastructure, putting it back up again. And it's quite complex because if you're doing this with a replication, you may have to fail over and then fail back to your DR site or take some other form of complexity. With a distributed database like Yugabyte, this is simple. You simply add some more nodes. After a couple of minutes, the database will do all the work and it will bring the nodes online. And you can keep on growing that either for capacity or for more processing response. This expansion and contraction is transparent, operationally transparent to the user. So when they add and take them away, the work happens in the background and the user is not impacted by that growth at all, no outage. So you simply take them away once you've passed your peak or when you don't need the capacity anymore. Another good example of operational resilience is built around the idea of operational excellence. So we do rolling upgrades. What happens with our system is that when you go to move from one version to the next, it does it deploys it on each of the nodes, shuts down one node, upgrades it, brings it back online with the new version, and so on and so forth. So gradually the database changes its version, and there's a point at the end where everybody has got the new version of the software, and it just changes the version, and it's still going. This is done with a minimum of disruption for the users. We combine our design with a very highly engineered solution, so it's easy to integrate with modern application development approaches that Olivier and Mark were talking about. What we have is DevOps mentality. We have RESTful APIs. We have Prometheus APIs to give you the monitoring stats. One of my favorite statistics is that in one of our services, there's 3,080 monitoring stats brought into a single console and single pane of glass for management. So all of this is heavily engineered and designed to work with the way developers work today. We have a management console we call Platform, which allows you to control those databases and allows you to access the API to add services, which also allows you to create the database as a service. The final area I want to just touch on is about the financial resilience. The idea here is that you need to build in cost avoidance. And there are lots of ways that you can do this. So we are 100% open source for the database. That means that's all the enterprise features and everything that you might need. It's covered by the Apache 2.0 license, so you know what you're getting. And because it's open source, you can actually choose, you only have to pay for the support that you need. You're not buying a mega license over to deal with these things. Because I've also talked about the less management overhead. Because it can be embedded into modern systems, you can spin up a database very easily, spin it down after you don't need it, expand and contract and embed it. There's less management. And this allows you to take those resources that have been looking after databases and allows them to become more productive. It allows them to work with teams in a different way. From the normal group of DBAs, they can be part of a squad or an agile team and focus on what you need to build more resilience into the system. I've already touched on the next point, which is the elastic scalability. Elastic scalability means that you're using the resources that you need just now. You're not paying for capacity that you may or may not use once a year. And if you look at some of the big events that are happening, like China Singles Day or Black Friday, and as more people become web-enabled with their technologies, these unpredictable bursts will happen more frequently and more unpredictably. And if you have a product which suddenly captures public imagination, they can get very much larger. We see this not only in things like shopping carts, but we also see this sort of event in things which are driven by social media, where systems of engagement like websites suddenly get very busy. So the ability to extend that database, which Yugabyte provides seamlessly for you, means that you can actually just pay for the resource you're using right now and expand and contract and take advantage of that. The other thing, and Olivier talked about this, about the migration, is our reuse of the PostgreSQL API. This is an important part of Yugabyte. With Yugabyte, you are getting Postgres. The way we have architected the system is that we've taken the Postgres query layer and we replaced it with our own engine underneath it. So the things that are important to Postgres users are there from the outset. What we get is the ability to use the Postgres extensions and the store procedures just like Postgres. You even can use the Postgres driver and talk to it on port 5433 compared to the normal 5432. This allows you to exploit your Postgres investment. And it's very interesting listening to Mark and Olivier talk about this, because what they said is we'd already started down the journey to Postgres, and actually moving from there to Yugabyte was a natural migration for them. It also allows you to open up the platform to a wide range of third-party tools. If they already talk to Postgres and work with Postgres, there's a very good chance they'll work with us. There are some limitations based around storage, but because some tasks aren't quite suitable for it, like data warehousing in a distributed database. But the rest of it all works. It also speeds up that adoption and removes training costs because it's a familiar set of tools. So if you're using an infrastructure like the VMware Tanzu or Spring Boot or any of those components, using Yugabyte allows you to just carry on using that and just swap over without any cost. We know that some people out there talk about being wired compatibility with Postgres, but that's not us. We have true compatibility with it. We speak proper Postgres, and that's an advantage for our customers. It's also about becoming cloud and infrastructure agnostic, and that's another important feature about Yugabyte. We run on-premise or in any of the major cloud providers, but we also run in a hybrid mode, which is built across on-premise and with the cloud provider. And we've seen this, for example, in migrations where people have two DCs. They're working on the two DCs, and we add Amazon or Google or Azure as the third data center, and now you have a distributed cluster, single database instance, running across all three. You are then free to move your services from the on-premise into the cloud, and that's part of your migration strategy. As you close down your data center, you can expand into other regions or other availability zones in the cloud and carry on using it. And what about getting locked in with a cloud provider? Well, again, it's multi-cloud. You can run across 2 clouds or even 3 clouds. You could have a database which sits in Amazon and Google and Azure if you wanted. But it's not just sufficient to run on any cloud. We also run on bare metal virtual machines, in Docker, in Kubernetes, and on the containerized service platforms like Tanzu and OpenShift. In fact, if they can run on a Linux system, it's likely that we can help. And what's important about this is it allows you to become cloud and infrastructure agnostic with regard to the database. And this is a way that will help prevent you returning to the sort of cost models associated with those traditional on-premise deployments. I'd like to finish with a quote from somebody we were introduced to recently. And it's perhaps one of the most telling things that I've seen with this. This is a London-based fintech CTO, and he said, "It's shameful that we still have a monolithic database. Without a distributed SQL database that runs in a cloud-native architecture, we won't have the organizational agility and the business resilience necessary to compete." And that's what Yugabyte provides, the opportunity to take advantage of cloud-native technologies and distributed SQL while reducing your cost and enhancing your resilience. And if you want to know a little bit more about us, we have a community Slack channel. You can find our code on GitHub, follow us on LinkedIn, and we'll be having more events like this and meetups, which you can find on our events page. Other than that, I think, Di, I'm ready to take any questions. Thank you very much, everybody.
Thanks, David. Got a bunch of questions stacked up, but I noticed Olivier's been answering the questions as practically as fast as people ask them. So that's great. Thank you very much, Olivier. But I do have a couple you didn't jump into, which I'd just like to throw at you, hoping that you're still happy to meet those. So data retention, there was a question. What are your thoughts on data retention / archive policies in the new implementation? Any thoughts, Olivier?
Well, sometimes it happens, but it hurts a lot, so I try to stay away from it. Yeah, okay, data retention. So when it comes to a business like ours, the data retention is actually absolutely key because we have a legal obligation to keep the records when it comes to everything related to financial activities. So for us, being able to be sure that we are not going to lose any data is absolutely key. That being said, we are evolving in a GDPR type of world now. So we need to be able to delete or access the data easily. We need to be able to justify that we store only what we need to store. This is where the archival policies are coming to play. So for this kind of stuff, what we do is actually we've isolated the various personal information that people can give us in dedicated DBs, in dedicated topics, also in Kafka. And this way we have dedicated strategies for those that are tailored based on the retention that we need to apply for this type of records. For example, if you transfer money to us, to a friend using us, your PAI will have to keep for almost ever. So we need to be able to have it in a dedicated space where we have a very tailored strategy. But all the data that we've generated along the way for that transfer, to orchestrate that transfer, is not necessary. So that stuff has a much stronger archival policy. And after 30 days, we delete everything we can. And so we've defined this type of rules when we moved to Postgres. Using them on Yugabyte meant absolutely 0 minute of migration because it was Postgres for us. So that's really what we've done.
Thanks, Olivier. And another question, in fact, there was a couple of references to this, was about migration tools for that data.
So It's funny. That was the first question I've asked my team when we went from MS SQL to proper SQL. You know, and sadly, there's not a magic tool that transforms this weird SQL to something that is NC. So you have to review. I mean, you've got some stuff that are fairly easy, the way you protect the columns, the way you protect the tables, subqueries, all this kind of stuff. You know, any guy familiar with your CLI Unix type of tools can do it with a bit of awk and sed and this type of tools, but not everyone enjoys it. What was complex was more about indexes, about query plans that you can't automate because the plans aren't necessarily the same, because between the MS SQL engine and the PostgreSQL, they don't resolve the query in the same way. PostgreSQL is way more clever in the way it's using indexes, and so you don't necessarily need as much, but you need them better, like double indexes. You can, you know, filter based on some values in your column. So that was the hard work, and so that is manual. You know that on the small DBs, it's fine. You don't really have to worry. On large DBs, it's a lot of load testing, it's a lot of analyzing and revisiting the indexing strategy. So that is clearly manual, and there is no tool that can help you there besides monitoring tools for your performance and seeing where your IOs are getting through the roof.
Thanks, Olivier. David, are you still around? Can I ask you a question?
Yes, I'm here.
You're back. Yeah, I see you've been reading the questions. So I'm going to do the same to you as I did to Olivier, which is the one you didn't choose to answer is the one I'm going to ask you, which is, because it's come up a couple of times, the one about latency when you're doing consistency across, you know, multi-zones and indeed failure tolerance. Can you talk a little bit about that?
Yeah, so what we have is the idea, as I mentioned in my talk, about a failure domain. So you can choose the level of your failure domain from something very local to an availability zone or region. And that's the fault tolerance level. So if you set the availability zone, you can lose an availability zone, but you can't lose, you could, if you used 3 AZs in one region and lost the region, you would obviously be down. So you're picking a level that you want your failure domain to work at. Once you pick that, that then impacts to some degree the latency of the write. Typically, for AZs, we're seeing anything. We're seeing figures which are less than 2 milliseconds for read, less than 10 milliseconds for write. And then you start to look at the questions, because there is a cost compared to running that in a monolithic database. It is slightly slower. But what drives most of these answers is about the throughput. People really rarely want to do it in, the difference between 8 and 10 milliseconds is not significant when you want to keep it at a rate of 200,000 transactions per second. It's about getting that throughput and meeting the business requirement and servicing. So the advantages you get and the ability to keep that at very high speed, very powerful. And we manage this just from those of you interested in the technology. We have a hybrid clock, and we use MVCC, multi-version concurrency control, to ensure that this is all working. And there's a couple of really good blog posts on our website for that.
Okay, thank you. And that was it. 1, 2, sorry, I'm just, another question I made a note of that I did want to, yeah, somebody asked the question was, so is it a good strategy to do a 2-step migration from master-slave failover, such as I'm familiar with, to replicated databases on Yugabyte, and then a second step to upgrade to the kind of the multi-data center type approach that you had on your slide? What's your thoughts on that, David?
It's something which is actually overhead. It takes much longer to build a failover and a replicated database than it does to create a single database instance in Yugabyte, which is already distributed. So we find that people, once they understand how the technology works, don't want to go through that two-step process because it is just adding complexity. It's saying we'll go from a complex infrastructure to a different complex infrastructure and then simplify it. Whereas logic really determines that you should go from a complex infrastructure to a simple infrastructure and remove the middleman out of the situation.
So in other words, you're saying although it might look simpler to kind of mirror the structure and then go on a step,
yeah.
Jump right in with both feet, or 3 feet, in fact, one for each zone.
3 feet. And actually, you'll find it's a lot easier. We see this as a recurring theme. People often come to us and say, what we've done is built an architecture which talks about 2 DCs and replication. Can you do that? We'll look at the other features later. And it's part of the process we go through in POCs to show people the benefits of using 3 DCs immediately without having to go through that intermediate stage. So yes, please dive right in with both feet, all 3.
I think there are a few more questions. There are some of them kind of dive down very specific questions. I know I just pointed somebody to the doc to answer one question. So I'm just scrolling back through those to find if there's anything.
While you do that, Dave, let me just say that if there are people who want to do deep dive sessions, that we do have a number of these on both recorded webinars. And if you're in EMEA, we're also planning to do some of these as a deep dive session, and you should contact Mark McNeil or any of our support team via the website. And they can sign you up for these events where we do a bit more technical deep dive than I've been able to get into today.
Yeah, so just to enlarge a little what David just said, basically starting in September, we're planning to do tech deep dives, kind of 1 feature per session, so that we kind of limit the scope and then we can increase the depth, and those will be tech only sessions. And as David says, they'll be announced. If you make contact with us, you will get informed all about those and invited to those. But just one more question I'm going to ask, and then I'm going to wrap, which was multi-cloud question mark. Does that mean some nodes on one cloud provider and the others rest on others? Olivier, do you want to talk about what your plans are, where you are right now on that? I know what David will say. I'll let him say it afterwards.
Well, yeah, it's I can answer that fairly easily. So we are running multi-cloud, not by desire, to be fair. It's more de facto whilst we are moving away from Azure. That being said, we want eventually to go back to being a multi-cloud type of business by desire, not on Azure, I would expect, probably more on a platform like GCP. But so right now, what we do is really that we have some services that are on AWS, the vast majority of them, and then the remains of what used to be our previous platform on Azure. So depending on what type of the systems you're going to hit, you're going to go in one or the other. We've got a bridge between the 2 clouds. So from an applicative point of view, it's completely transparent for the systems. But there are some stuff you can't operate on a multi-cloud perspective. And this is where systems like Yugabyte are very interesting. In my previous job, we had issues with very large DBs also that we wanted to run on a multi-cloud basis, and we couldn't find a proper solution. So having services, the compute part of the service is always the easiest part, but the storage and the DB especially is complex. So Yugabyte provides us with a solution for a problem that really we couldn't address otherwise.
Okay, thanks, Olivier. I'm going to ask one more change of topic because a couple of questions just came in very recently on this, which is change data capture. I'm going to ask you both to comment on this, but David, can you go first?
Yeah, so we have changed data capture that we've got the ability to go to Kafka, I can't remember the word, the opposite of sync, connectors, so that we can emit those messages. And there are some of the third-party tools that do change data capture with Yugabyte. We don't use the Postgres wall because that's part of the underlying storage layer. We replace it with our own. So as vendors and clients coming to us with various change data capture options, we are evaluating and deploying them. One of the things about growing and working in such an agile way is we're actually able to turn these features around for specific tools and things quite quickly if there's a reason for doing it. Inherently, if you're doing replication between our database instances, we use our internal proprietary change data capture to do it as well, which normally suffices for a lot of people.
Sorry, David, can I just clarification for my own ignorance? So what you're saying is change data capture between Yugabyte databases is managed as an internal proprietary feature, part of the database, not via third-party change data capture tools.
Yeah, so I talked a lot about the need to have the opportunity to remove replication, but occasionally we do have people who come to us with a genuine replication requirement. And so, as well as the features we've talked about today of distributed universes, we also have the ability to replicate between universes, and that change data capture between those is entirely internal and proprietary. It actually uses the same messaging structure that we've got for commits. It just does it asynchronously to the other nodes. So it's very cheap.
A special kind of transaction.
Yeah.
Olivier, did you want to talk a little bit about your integration of Kafka and databases?
Yeah, sure. So the way we're operating is, so we're using an architecture type of design that is called orchestrated sagas. So what it means really is that you have a series of microservices that are going to communicate using Kafka as a messaging bus to send queries, commands, so they can ask for the next step to be done. But all of this is supervised by a central type of microservice that orchestrates effectively the journey between the various steps of that saga. And a saga is, it can be considered as an atomic operation, something that cannot be decomposed further. And during that saga, you've got, therefore, each microservice that is going to be involved has their own database, and within that database, it's the temporary states. So we've got an update from Kafka coming that's going to trigger an insert in a row or an update in a row somewhere. And then the service is going to pick it up, do what it has to do, and then the row will be deleted or flagged as processed. So when it comes to Kafka with DB, for us, it's fairly easy, really. And keep in mind also that our DBs for all these microservices are fairly small, because we are talking only about dozens of gigs, really. So it's really tiny. So each operation is executed in a matter of milliseconds. We don't have locks. We don't have, the usage of the transactions are fairly limited also in the sense that, we are rarely operating on more than a couple tables per operation. So everything is really streamlined and kept as thin as possible. And it's just to manage the state. And as soon as they are done, they send a message back to Kafka. So that's it. And after that, we have a plan to have a few DBs that probably are going to be hydrated using the Kafka connector that Yugabyte provides. But that's for us the next step, and that's going to be used more on a data analytics type of strategy.
Thanks, Olivier. Well, I think actually, although I'm still seeing questions coming in, both in the channel here and back channels, So I think we could probably go on for a while yet, but I fear we're running out of time. So I'm going to wrap it up now. But what I will say to you is I'll reiterate some of what David said before about contacts. Please do follow up if you didn't get an answer to a question that's important to you, and we will try to take the questions we've left unanswered and take those offline. And if we can identify your username with who you actually are, if we've got a contact, then we will get back to you on those. But if we don't, then please ping us and chase us about that, and also what I talked about before, which was the series of tech deep dives that we're going to start in the autumn in EMEA, where we can explore some of these maybe in greater depth. But with that, I'd just like to say thank you to WorldRemit for Mark, now gone, and also Olivier, and thank you very much also to David, and thank you to all of you guys for turning up and for giving us a really interactive session at the end of the day. That's it for me. Thank you very much, and see you next time. Bye now.